Alright, so we have a calorimetry question here, just like the lab that we did and just like the stuff we've been doing in class. So you have a piece of metal that weighs 59.047 grams. We heat it to 100 degrees Celsius, put it into a 100 milliliter water bath at an initial temperature 23.7 degrees Celsius. The metal and the water come to an equilibrium temperature, which is 27.8 degrees Celsius. Assume that there's no heat loss to the environment. Calculate the specific heat of the metal. So first we have to calculate the heat absorbed by the water, then use that value for Q to determine the specific heat of your metal. So we have to first determine Q, or the heat of the water, okay? Which ones we're going to use are M of the water, mass of the water, our specific heat of water, and our change in temperature of the water, okay? All of this takes place in your calorimeter. So this is your little calorimeter. You've got 100 milliliters of water, and you put in a block of metal, okay? You take the temperature, that's our thermometer, looks like a thermometer. You take the temperature of the water, and that allows you to determine how much heat was absorbed by the water when you added the metal. Okay, if we want to find the heat of the water, we need to have the mass, the specific heat, and the change in temperature of the water. Okay, so we see that the mass of the water we don't have, but we know that we have 100 milliliters of water. So we use the density is 1 gram per milliliter. Okay, so if we have 100 milliliters of water and your density is 1 gram per milliliter, we can use dimensional analysis. 100 ml, 1 gram per milliliter. Milliliters cancel out, and we have 100 times 1, which is 100 grams of water. Then we use the specific heat of water, which comes from your reference packet, okay? And we know that from our reference packet, the specific heat of water is 4.18 joules per gram degrees Celsius. And then the change in temperature of the water, delta means change. The change in temperature is final temperature minus the initial temperature. So the final temperature of the water was 27.8. The initial temperature of the water was 23.7. Okay? If we do that calculation, we get that Q, or the specific, or the heat of the water, is positive 1,713, or 1,714. Our units, grams cancel grams, Celsius cancel Celsius, joules. Okay, and we know that the units for heat are joules. Then we have to use our knowledge that the heat of the water is equal to the negative heat of the metal, okay? And that's because in calorimetry we have conservation of energy. Conservation of energy tells us that all of the heat absorbed by the water was lost by our metal. So we can calculate the specific heat of the metal using the same Q equals mc delta T equation. So we use Q metal is equal to the mass of the metal times the specific heat of the metal times the change in temperature of the metal. Okay, so our negative Q, so we have negative 1,714 joules that we calculated up here. The mass of the metal from the question was 59.047 grams. The specific heat of the metal we don't know, so that's our variable, that's our unknown. And the change in temperature of the metal was started at 100 degrees Celsius. It ends up 27.8. So final 27.8 minus your initial, which was 100. Okay, we want to rearrange the equation to solve for C. So what we have to do is divide both sides by 59 times your delta T here, which was negative 72.2. So C is equal to negative 1,714 joules divided by 59.047 times your delta T, which is negative 72.2. So your specific heat of the metal, move this over, ends up being 0.402 joules per gram degrees Celsius. Our negatives cancel out, we end up with a positive value for our C. So that's our specific heat of the metal. Another type of question you might see, you have in a coffee cup calorimeter, you have 100 grams of H2O, water, 100 milliliters of HCl, acid. They're mixed. The HCl has an initial temperature of 44.6. The water is initially at 24.6. After the reaction, the temperature of both substances is 31.3. We want to know whether the reaction was exothermic or endothermic, and we need to give an explanation. Okay, so to know whether the reaction is exothermic or endothermic, first we have to define our system and we have to define our surroundings. Luckily for us, whenever you have a calorimeter, your water is always the surroundings. Okay, so water is the surroundings, and that means your HCl, which was mixed with the water, was your system. Okay? Your surroundings, your water, was originally at 24, and the temperature changed to 31.3, which means that the water absorbed heat in order to increase the temperature. So it absorbed heat, which means this is endothermic. Your system went from 44 degrees Celsius to 31.3 degrees Celsius. Your system then must have lost heat, temperature went down, your system lost heat, which means the system was exothermic. Okay, so don't confuse heat with your change in temperature. If we actually wanted to do a calculation for heat for either of these, we would have to use that Q equals MC delta T. Delta T, the change in temperature, is just a parameter that we use to calculate the value of heat. Okay, so we can actually calculate how much heat the water lost or gained. We know that it gained heat, so we can use our Q water, which means we're going to use the mass of the water, the specific heat of water, and the change in temperature of the water. Okay, so the mass of the water, it tells us in the question, 100 grams. So we don't have to, like up here, we had to use dimensional analysis and the density of water to figure out how many grams we had. Down here, we're given 100 grams of water. So we just put in 100 grams. We know that the specific heat of water is 4.18 joules per gram degree Celsius. And our change in temperature, final minus initial, so the final temperature was 31.3 degrees, and the initial temperature of our water was 24.6 degrees. Okay, if we plug all of that into our calculator, we end up with 100 times 4.18 times 6.7 was our change in temperature. Notice our change in temperature is positive, which matches with our endothermic reaction. Okay, remember, endothermic means you've got a positive change in temperature or a positive value for heat. Exothermic, you have a negative change in temperature or a negative value for heat. So when we do this calculation, we get that the heat of the water was 2,800 joules. It's positive, absorbed by the water. Okay?